Hey everybody, welcome to another episode of the Subnet Show. I am Gabriel Cardona and I'm joined as always by my amazing co-host Connor Daly. What is up, Connor?
Hey, not much. I think I need a better intro name. My amazing co-host is one thing. I don't know. I'm thinking the man with the most cats in crypto.
Okay, we can go with that. A big title to take on, but yeah, we can go with that.
Well,
So
I've got a lot of cats, so
I don't know. Some crypto kitty rich people might start coming in here.
that's
yes.
fair. That's fair. I don't have any real crypto. I don't have any real crypto kitties. I only have four physical felines.
Yeah, you'll have to tokenize them at some point for sure. All right. Well, thanks for joining us, Connor. As always, it's an honor and thank you for your time. So we have the official best friend of the podcast now, the man who's been on more than anyone else. We are having back for his second time on this show, Stephen Buttolph. Stephen is the lead developer on the AvalancheGo project. He's on the platform team. He actually created AvalancheGo. For regular viewers of the show, you may remember he was here on August the 12th. And we got to hear about his crypto journey and how he was the creator of AvalancheGo and one of, if not the very first engineer at Ava Labs. So Stephen is an absolute wealth of knowledge. He knows a ton about this project and this industry and this technology stack. And since he was on, we've actually had two Apricot Phase upgrades, 3 and 4. One of them went live today, just about an hour and a half ago, and it was totally smooth. So it seemed like an appropriate time to have Stephen back on to kind of touch bases on some of the cool things that have happened since we last chatted. So how's it going, Stephen? Welcome.
Hey, yeah, no, I had a blast the first time, so I was super excited when you asked me back, and yeah, no, really looking forward to it. And yeah, no, we've had a busy couple months releasing a bunch of network upgrades, and everything's been going pretty smoothly. So knock on wood, but really happy with how things are going, and really happy with today's release. So yeah.
Yeah, so let's kind of go back to you were here on 8/12, I believe the date is, and on 8/17, I believe we went live with Apricot Phase 3. The primary release feature was dynamic fees. I know there were a couple other things as well, but the big one was dynamic fees. So I'm not sure how much you want to say about that, or if that can just kind of roll over into the Apricot upgrade we had today. But let's touch on that a bit. How did dynamic fees go? What exactly did that bring us, and how did the rollout go?
Yeah, so really going back to kind of when we launched mainnet, post mainnet, we focused on a lot of features, but we were also focusing on a lot of kind of reliability and performance related things. With AP3, Apricot Phase 3, we started to feel kind of pretty confident in our software, and that everything seems to be kind of battle tested and pretty well proven. And so at that point, we kind of started looking into, what's kind of our biggest reason why people might not be able to interact with our platform. And of course, fees is always a high priority concern. So AP3 was kind of a long-awaited dynamic fees push. And so that ended up decreasing the fees by a pretty significant margin. We didn't want to necessarily put too wide of a range on the dynamic fees, just because we wanted to make sure that everything worked in kind of a production environment, because it's so difficult to actually test how things work on a public network like mainnet. Of course, we have Fuji and we have like internal test nets and various things like that, but really mainnet is a whole other beast. So we didn't want to push something out and just have some major DOS vulnerability get opened up, or pushed out and fees skyrocket or something like that. So we decided to bound it pretty tightly with AP3. But after we got some of that like much needed information for kind of what the results of that algorithm was, we ended up doing a little bit of tuning of the algorithm based on some community feedback, and then with AP4 we kind of loosened the bounds a little bit. So we decreased the minimum fee pretty substantially, and then we also pretty much removed the upper bound because the upper bound was essentially insignificant. We were never really hitting that. So So yeah, no, so that's kind of our fee story as of late. It's been really exciting. We're able to reduce the fee by, if I start throwing out numbers, I would be wrong. So I'm not going to, but very, very significant reductions. And I think the community is always very happy when we're able to kind of make the system more usable and more user friendly. So yeah.
So for a little bit of a history lesson here, when the initial, so for the first 9 months of Avalanche's existence, the fees have been entirely fixed, or the gas price has been fixed. So it started out at 470, I believe. 470.
Actually, let me jump in there.
GWA.
Yeah, let me jump in there real quick because I think you highlighted something that's significant. We're talking about the gas, which is the gas price implies that we're talking about the C chain. So the dynamic fees that we're talking about, these are C chain specific, right? This is not XMP chain. Okay, thank you. Go ahead, Connor.
Yep. So this is for the EVM chain. So when we started out, we didn't have the functionality to do dynamic fees. So obviously we added that recently. So I think when we were trying to decide as a company, like what is the right point to start fees at, this was based on like our $3 token price or our 50-cent token sale price. And so a lot has changed from the pricing perspective of the Avox token has increased in value significantly.
It's gone up from the pre-sale price was 33 cents. There were 3 different buckets in our token sale, one of which was 50 cents. So if you go from that 33 cents to the recent $76 all-time high, that's an increase of 23,000% over the last 13 months or so, which is, absolutely radical. So something to keep in mind.
Yeah. So this is like a huge increase. So when we had static fees, that was something that the fees were not coming down with the token inflation. And so it was costing people more and more money to transact on Avalanche. That was, I think, one of the biggest criticisms we received externally, which I think was a valid criticism. Is that we were just getting too expensive and we weren't cheap enough to compete with Binance and some of these other chains. And so dynamic fees was a super important upgrade for us. And we did half the fees one time. We did go down to 225, but I still don't even think that kept up with the pace of demand. And I guess one question I have for you, Stephen, is, why were those bounds set in the first place? Why not just arbitrarily set the, if we're so scalable, can't we just set the fees to like basically absolute zero? Like why do we have any kind of bound that's like, greater than a penny?
Well, so really, I think that what it comes down to is we just we want to make sure that we don't open up any unexpected DOS attacks. Our network is extremely young. Even though I think we're about to hit the 1-year mark. You look at networks like Bitcoin and Ethereum that have really been battle tested and really hammered. They weren't as polished as they are now, especially at a year old. So there's a lot of work that goes into maintaining a extremely complex and large distributed system like this. And we want to make sure that we don't cause ourselves any problems. So we wanted to really kind of get into a point where we felt that we were comfortable with from a tech side, and that we can kind of go up from there. I know I've run really cool benchmarks on internal networks, and we've seen extremely high levels of throughput and very low latencies there. But at the end of the day, like again, as I kind of touched on, like mainnet is a very different beast, and we just want to make sure that we always put like safety first and make sure that nothing bad happens. So I think that's kind of really our intention. We just want to make sure that people using our network have a good experience. So yeah.
Yes, and so are these technically speaking EIP 1559 style dynamic fees, or is there something special or unique about our network's fees?
Yeah, so with dynamic fees, we ended up releasing them around the same time that Ethereum launched EIP 1559, which EIP 1559 was the most radical fee change on Ethereum since its creation. So we use EIP 1559 transaction types inside of the C chain. with this network upgrade, but the underlying fee mechanism is slightly different. It is very similar, but it has to be modified because we have a asynchronous block issuance model. So in Ethereum, blocks are issued in expectation around every 12 seconds. Whereas for us, the block issuance could, depending on the usage of the network, it could happen every, 5 minutes, 10 minutes, or it could happen every, 50 milliseconds. So we've really seen, very large differences, for example, on like internal networks versus Fuji versus mainnet on that. And so we had to, modify some of the algorithms. It was actually really interesting because when we were discussing dynamic fees, we kind of came up with our own algorithm. And we were, of course, paying attention to Ethereum. I think everyone in the space pays attention to Ethereum and kind of what they're planning on doing. But we were able to really fit the mechanism that we came up with pretty gracefully into the EIP 1559 framework, which is really important, keeping backwards compatibility for tooling like MetaMask and such forth. So yeah, it's kind of the history there a bit. But.
So yeah, quick question. So then I guess an obvious question is, why didn't we just use Ethereum's, Ethereum has dynamic fees. Why didn't we use the same fee dynamics from the get-go? Is it because of the block rate, or is it because we burned the fees and they weren't miner rewards, and so you didn't have the same auction dynamics? Or
yeah, it's because of the block rate. So in Ethereum before EIP 1559, it was just a pure first price auction, and that's fine if there's a bidding window. So in Ethereum, their block time acts as a 12-second bidding window. The transactions come in, everyone bids for those slots. Whereas for us, we didn't actually have a bidding window because blocks were issued asynchronously. So we really needed some sort of a network agreed upon gas price, which didn't exist on Ethereum until 1559 with the introduction of the base fee. And so for us, it was easiest, at least to start with, by just requiring a minimum price. So,
just curious, so why do you actually need a time window for that kind of auction? Can't you just take like the transactions in the mempool with like the highest gas and then just fill your block with those while there's things in the mempool?
Sure, but then you end up running into some DOS vulnerabilities, right? Because at that point, what's to stop someone from just spamming zero fee transactions? And if people are just sorting by max price and issuing immediately, well, because there's no block like delay, they're just going to issue that block immediately. And so you could have just if the price is minimum, then you can have an infinite number of blocks just being issued, right? Depending on how that works. So you have to be careful with those kinds of things. Yeah.
So I guess there's also some dynamics at play because the block producers in Avalanche do not take a block reward. Whereas, so if you don't have that same incentive to like pack as much into a block, then you can potentially let some, there's different incentives at play, which change the behavior of that mechanism.
Yeah, I think really the requirement for like block proposer rewards is really tied in with the amount of work it takes to propose a block. In proof of work networks, it's obviously extremely expensive to propose a block, and that's why they have block rewards in addition to the fees of the transactions being put into it. Whereas for Avalanche, because we don't have proof of work, we can just build a block and issue it out. So I think that the rewards on like a block issuance perspective is kind of less important in proof of stake networks in general. So.
Yeah, so that's something, again, I think we've mentioned it now, and I'll mention it again a third time because it really is a big thing to wrap your mind around. I've seen so many teams that we've been on ramping get confused by this. I see it weekly. If you go to our C-Chain Explorer, sometimes you'll see the average block time is 3 seconds. And that'll cause somebody to say, but I thought you guys were sub-second finality. And it speaks to the asynchronous nature of our block production, that basically the network is truly quiescent. It will just chill out and do nothing if there are no blocks moving across the network, and then it will accelerate if there are a bunch of blocks. So it comes up, sometimes you'll see the average block time is, 222 milliseconds or something like that, which I believe really is like the lower bound, I think, of what's technically possible. I could be wrong there, Stephen, correct me if I'm wrong. Or yes, so, but yeah, it's just worth noting that there is no average block time in Avalanche consensus. That's just not the way it works. Okay, cool. So I think we've touched on dynamic fees, and I think that can now lead us into the other big upgrade. So today was Apricot Phase 4. It went live probably around 2 hours ago. From what I understand, there was 0% downtime, so it seemed like a pretty flawless network upgrade, which is always a pleasure. I know even watching from the outside, it always feels good. So it must feel really good being on the platform team and having those things go off. Anytime you can upgrade a value-bearing network that has, so much value on it, and go between phase shifts, it's a tense moment into a very feeling great kind of moment. So congratulations to you, Stephen. I know you've been clocking in crazy hours getting all this prepared. Why don't you give us the super high level on what went down with Apricot Phase 4?
Yeah, so the entire platform team has really put their heads down the past couple weeks specifically to kind of finish off this thing, but it's really been a work in progress for a very long time. I think the specification for it, I think, was kind of finished in around March. So it's been a long time kind of in the works, and especially the past few weeks to a month, the whole platform team has really done a phenomenal job, just kind of providing the finishing touches and stuff. But yeah, so Snowman is at its core, it's built out as a contention reduction mechanism. So what we were seeing on mainnet was essentially the network was doing useless work during times when during kind of high throughput times. So what that means is a bunch of block proposers proposing blocks at the same time at the same height. Now with Snowman, the consensus mechanism, that's fine. We end up powering through it and accepting those blocks, but we still take time to validate the blocks. We have to, perform like a login slowdown on the number of like queries of network and things like that. So it does end up kind of adding up. And with Snowman++, the idea is to essentially designate a proposer list to be able to propose blocks. And we saw a major reduction in contention on the testnet and in internal networks. And additionally, we've seen a huge reduction over the past few hours or so on mainnet. So we're really excited about that. And additionally, it ends up allowing us to introduce a more kind of standard network mempool. And so now we see a really nice kind of behavior that people are accustomed to, which is that you can pay more if you want a higher priority on transactions. So I don't think that that's really something that is super important with the state of our network, because we can easily handle all of the load that we're given. But kind of as we're scaling up, it's kind of future-proofing our network to make it kind of more resilient and handle extreme levels of load. So yeah, really happy with kind of how the entire Snowman++ has been rolled out. Yeah, I think so far it's been a huge success. So.
Yeah, that's awesome. So let me just recap a little bit. So I think that the biggest problem that you mentioned that we were having before is called contention. So this is when we have two people both submit a block with the same block height or block number. So there's two block number 5s that are proposed at the same time. And the network has to choose one of them because there can only be one block number 5. And we don't necessarily distinguish like which block is better. You could have one block that's like really dense and really full, and one block that has just like one transaction in it. And I think it's basically all else being equal 50-50. There's no like preference for we always take the denser block or something like that. And so that means, if we choose the sparse block, then all of those transactions that were in the dense block are going to need to be resubmitted for block number 6. And because of this, there was a lot of people who were not submitting dense blocks to the network, and that was causing some increased latency as these denser blocks were having to be reissued with all their transactions coming through. And so now we're moving forward with a different approach that allows us to kind of prune down who can submit a block at any given time, so that we have less people proposing blocks at the same time. So there's less conflicts, and we just have one choice for block number 5, and we just determine, is this a good block or a bad block? And if it's a good block, then we can move forward with it. Then we just move on to 6 and 7, and we don't have to constantly be choosing this block or this block.
Yeah, exactly. Yeah, we saw some blocks that had as you mentioned, extremely small 1 transactions, and we saw other blocks that had 40 transactions. And the consensus mechanism essentially follows a first come first served preference. So if the block was issued first, then that's the one that it's going to prefer and try to accept. And the network will eventually come to an agreement. But if the majority of the network sees a block first, then that's the one that's going to be accepted. So yeah, we ended up being able to introduce this kind of proposer scheme, and yeah, we're seeing amazing results on the number of processing reorgs versus rejected blocks versus accepted blocks. So it's been yeah, amazing. So.
And it's worth noting that AvalancheGo v1.6.0 has protocol optimizations which are not compatible with prior versions, anything less than 1.6.0. And so your node will be marked as offline if you haven't upgraded, basically by the activation time of now. So that means that other nodes are going to be reporting your node as having uptime problems, and that could jeopardize your staking rewards. So as a reminder, you want to upgrade your node as soon as possible. What were the stats? It was like 97 or something that have upgraded, 97%, right, Stephen, or more?
Yeah, I think around the network upgrade, we were seeing around 97.8% participation running 1.6.0. So there's the last 2.2% of kind of last couple stragglers. But I think as we continue talking here, I have a little dashboard up on my left, and I can see that number continuing to go up. So we're getting back up to where we were at before, which was greater than 99% participation.
Yeah,
which is phenomenal. I just want to say, our community has been extremely great on kind of maintaining their nodes, upgrading their nodes on time, and yeah, so big shout out to them, because I can guarantee you this network does not work without them. So yeah, it's been great.
Yeah, massive shout out to Jovitsa, who's helped drive a lot of that energy through the Discord channel. Dan also helps a lot, and Yulin helps. There's a ton of people. Patrick obviously helps, but I think Jovitsa deserves a special hat tip for really being incredibly hyper proactive and just go ahead.
Yeah, I was just saying, speaking of community members, reminds me when we had our network issue in February. We ended up rolling out a release at 2 or 3 a.m. and so much of the network, it was within an hour, it was 80% or 90% of the network had upgraded. And I just remember people talking on Discord and Telegram, and we're just be I knew it was coming out tonight, but I needed to go to bed. So I just left my notification sound on, and when I heard it, I got up out of bed to go upgrade.
Yeah, just props to our community. Our community is absolutely outrageous. I mean, it's one of the special things about Avalanche, of course, is just simply that the community is so incredibly proactive and so super involved. I'm hearing a little bit of crunch from somebody. Are you guys hearing that? Check. Okay, let me know if you guys hear it. So yeah, something I just wanted to round out that thought. There is actually a stats dashboard. You can check out stats.avox.network, and you can verify that your validator is online and healthy. That's something that's worth checking out. Okay, so I'm just checking out my notes to see where the conversation flow was going to go here. So I wanted to say there was really 3 high-level bullet points that were part of v1.6.0. There was, of course, Snowman ++ around contention. There was reduced C-chain transaction fees, and there were also block-based fees. Is there anything else that we want to touch on with regards to Snowman ++? It seems like an incredibly huge update, and I just want to take this opportunity. Is there anything else we want to touch on there?
So I think we've already talked quite a bit about the the proposer side and the reduction in fee side. And then I think the only thing that we haven't really talked about too much is the block-based fees. Essentially, the block-based fees is enables a mechanism for kind of prioritizing block production. So we want to essentially, move things forward in the network faster if people are willing to pay for that. And so the introduction of block-based fees is essentially being able to subsidize blocks to get them to go faster in the network. So we don't want to necessarily always issue extremely fast blocks because again, we have, we want to keep our hardware limits low. We don't want to lose people on the network that are really far, out away from, I think the most common place and for our nodes right now is probably US, area, maybe some in Europe, but, I love our nodes running in Australia and stuff, and I don't want them to just, get completely murdered by network latencies. So, yeah, that's basically the introduction of the block-based fees. So, yeah, additionally, I think one thing that has come up a lot is kind of questions around MEV. So maybe we could touch on that. But I think with MEV, it's very interesting because I think some of the conversations around Snowman++ kind of focused on MEV, and that was definitely not the intention, right? The intention was to make the network faster and easier to use and kind of a better user experience for people. And I think that some people kind of felt like MEV was the intent, and it was definitely not. So certainly when you introduce a proposer mechanism, it can introduce new types of MEV that were perhaps more difficult in the past. But I think MEV is a very complicated issue. There's definitely people more, suited to talk about it than I am. And, I would never claim to be an MEV expert by any means. But I think that at the end of the day, kind of we decided that we wanted the health of the network to kind of come first. So yeah, that's kind of my stance. If you guys have any thoughts on MEV?
Yeah, sure. I want to jump in. So just first, just in case anybody's not familiar with MEV, so that stands for minor extractable value or maximum extractable value. And basically, it is any extra money that a block producer can make by inserting transactions, censoring transactions, or reordering transactions. And so there's kind of a few broad categories of MEV. I think the first is arbitrage. The second is loan liquidations. And then there's also sandwich attacks, which is kind of a form of front running. And then lastly, there's kind of just everything else. And so there's a lot of smaller dApps, but especially on Ethereum, the highest visibility ones are, the DEXs, the lending protocols, but then there's lots of small apps that are less visible, harder to see. And so I think one thing I wanted to make clear is not all MEV is bad. There's definitely some good MEV, but it definitely gets a bad rap. And there are certain forms of it, which I think most people would agree are pretty slimy. There are so just to start off with, a good example of MEV is arbitrage on DEXs. So if you go to Pangolin, if you go to Uniswap, if you go to do a swap on a major token that has lots of liquidity, you're going to get a good price. You're going to get the market price. And the reason for that is because of arbitragers. Arbitragers will check whenever the prices are out of line with the market, and they will go and they will be able to, they will move the price to be what it's supposed to be. And this is really great because you should always do your own research, but you don't really need to do your own research to check, is the price I'm getting good? You can kind of just assume it. Always do your own research, not financial advice, but for the most part, you're gonna get a good price. And that's an example of MEV. And I guess the question is also not exactly is MEV good or bad, but who gets to claim it? And does it become a winner take all scheme where one person, or the person with the fastest or best located computer is earning all, or the most stake is earning all of the MEV themselves, is getting all of these arbitrage opportunities? Or is it kind of something that is equally distributed to a bunch of different people, maybe weighted by a stake weight or something like that? But then, there's also some bad examples of MEV, like sandwich attacks. So these are the most famous bad examples. So basically, if you're familiar with front running in traditional stocks, it's the same kind of thing. If I can just look in the mempool to see, what transactions are coming next, who's going to try to make a trade, and then I will try to make a trade before them to make sure that they get a worse price, then allow their trade to go through, and then arbitrage the end result. So I can basically extract a little bit of money from you, a little, just a little bit within your slippage tolerance, but just a little bit adds up over lots of different transactions. But effectively, you, the user, are getting a worse experience, and I'm profiting from being a middleman.
And I just I want to step in there, because really, in a sense, like, is there something wrong there, right? So like, you ask yourself question, like, I'm sure this isn't an ethical issue, so I'm not trying to overkill it, but like, is there anything wrong there? Is this just a symptom of somebody who is able to understand the mechanics of the system better than another person and is somehow able to, make a little bit of an edge there and make some money? I mean, effectively, that's what's happening. I guess the question comes down to, like, where do you sit at it with it? How do you feel about it? If you're the person who's losing out on the deal, presumably you're not too happy about it. If you're the person who's coming out on top about the deal, presumably you put a lot of work into this and you're probably pretty stoked about it. So it's just an interesting thing. It's not like robbing somebody, right? It's not that clear cut that you're doing something which is not necessarily wrong. I'm sure there's plenty of people who could just make the argument of, hey man, this is just the way the system works, and I'm simply taking advantage of the way this game is set up. Don't hate me, hate the game, But it's interesting when you think about it that way. Really, somebody's just paying attention to what's happening, trying to get a deal in before you, and maybe making a little bit of the cut. How you feel about it very much probably depends upon which side of the deal you're sitting on, right?
And this isn't something that's necessarily restricted to crypto. This actually was started in like traditional finance, and like this was actually like Robinhood's business model for a while. It's free trading because we're front running you and we're selling this is like high frequency trading. This is like exactly
I didn't know
what
that.
they do.
I had no idea that was what they're doing. It's interesting.
Yeah, they sold your transactions to high frequency traders, so you always would get a slightly worse price than they would show you on screen.
It's a little bit more complicated than that, because that is just outright illegal. But they definitely
they got like sued for it.
Yeah, no, it's
okay. So the
order flow
this is it.
But
okay, so there is some type of law based around this. So it is a little bit more. It's not as gray as I thought. There's a little bit of actual black and white to this.
So I think that the gray part really comes in with I would say like decentralized exchanges, because traditional finance is extremely heavily regulated, and regulation in crypto is we could have podcasts on podcasts just talking about that. But in the traditional world, right, like there are pretty strict rules with customer data and customer orders. Again, not an expert, but I like just blatantly front running user trades is not allowed. I think one thing that people have kind of talked about is like this thing called payment for order flow, which essentially means that Robinhood, for instance, could essentially send the transactions to the exchange that they want to send it to. So they aren't necessarily looking at what the actual trades are, but by sending those orders to a specific exchange, they might be able to gain benefit out of that, perhaps with fully legal things, but it gets complicated at the technical end. So again, not a lawyer, I have no idea about details, but it's very complicated. So
yeah. Well, I think when it comes to things like sandwiches on crypto, I think where I come down on it is that one of the big selling points for crypto was that we were taking out the middlemen. We were building these decentralized protocols, so there were no gatekeepers and middlemen. And that's one of the things that people really hate about Wall Street when it comes to like DeFi, is that there's all these HFT middlemen and all these banks who are just trying to separate you from your money. when you should be able to do things that should be free, that just it seems like everybody else can do. And we try to build that in crypto, and it turns out we're just giving money to validators or miners or whoever, and we're just creating a new class of middlemen, and we're not actually doing anything that's paradigmatically different. We're just shifting who is taking that cut.
Very
So
interesting.
if we want to be different, then we have to come up with some different solutions.
Got it. So then in the context of Snowman plus plus, this was mentioned in what context?
There were just a lot of kind of interest around it, around like the potential implications of MEV. So
Gotcha.
again, I don't say that I'm really qualified to talk about all of the implications, because as we've been talking about this probably for what, 10 minutes now or so. It's extremely complicated and very interesting. But yeah, so there's I think pros and cons. I think that we'll kind of see as the network unfolds, kind of the behavior that happens, and we might have to kind of iterate on stuff to give people using the network the best experience that they can, and hear feedback from the users and community. So
Okay, cool.
Yeah, and so I think that like the reason that it's so entwined with Snowman plus plus is because Snowman plus plus changes the block production mechanism. And so basically previous MEV strategies just don't work anymore. It's not necessarily better for MEV or worse for MEV, it just changes it. And so there's communities of searchers and extractors, I don't know, miners, who had our bots running on Pangolin and stuff like that, who just now need to make changes. They now need to figure out what the new rules of the game are. So the rules of the game are different. Are they net better, net worse? We'll see. Probably about the same in the long run, I would guess. But there's just conversation around it because, and also just some talk on Twitter that people go back and forth.
Okay, gotcha. So then I think there was one more component. We had talked about Snowman plus plus. We had talked about block-based fees, and then let's kind of touch on the reduced C-chain transaction fees. So I know we had a dynamic fee algo called Moderato, I believe, that was part of Apricot Phase 3. And then let me see, I have notes here. It says, since AP3 activation gas prices averaged around 98.2 nanowatt-bucks, a 56% reduction from AP2. So, obviously the price had gone down. We had this Moderato algorithm that we were using. And then now I believe we've actually changed the upper and lower bounds. So I know that recently in the AvalancheJS build I pushed out yesterday, we put a constant in there for the minimum gas price and the maximum gas price. Do you want to touch on that a little bit, Stephen?
Yeah, so I think it really just kind of touches back on us being more kind of confident in our system. When we first rolled out Moderato, we didn't want to see some wildly swinging gas prices, because again, mainnet is a totally different beast, and we just don't want to impact people negatively. But I think based on what we saw on mainnet and our statistics, we felt a lot more comfortable with it. So we ended up kind of tuning a couple parameters and kind of widening the bounds and really letting the algorithm kind of shine through in its own right. So I expect the fees to go down. I'm pretty sure they already have. I don't have that window open, but I would expect that they're going down as we speak, or But
And what
I
is
think
what is the range now? What is the upper and lower? Is it 25 and 1,000?
Yeah, so 25 and 1,000. So I think I saw one question about like why the upper side increased so much and the lower side, decreased. So it went from the low side was 75 and the high side was 225 previously. So now the high side is 1,000 and the low side is 25. So based on kind of our metrics that we were seeing, we were really never hitting 225 for the most part. It was happening during spikes, but for the most part, we were never really hitting it. And so we felt pretty confident that our upper bound wasn't really a big concern. But on the lower bound side, it was pretty frequent that we were pegging to 75. So we didn't want to just drop the floor out, set the min price to 0 and just move forward. So we're going to continue kind of analyzing it and making sure that everything's working correctly. Yeah, that was kind of the rationale there, and I think that we'll see continued reduction, especially with kind of the reduced contention and the introduction of the block-based fee. I think we'll see a continued decrease in fees. So yeah, I'm excited for it. I think it'll look good.
Cool. Yeah, we asked out on Twitter yesterday, and I think you just addressed a few of the questions right out of the gate. So it says, one of the questions from DeFi Cash Flows is, it appears with the new update, the low end gas fee dropped farther and the upper tier of gas fees increased by a high percentage. Can he share his thinking behind this? I believe you just did. The next one was maybe not a question for Stephen specifically, but given the minor tweet storm recently surrounding Snowman++ and MEV, how big of a concern is MEV? We just discussed that. Excellent. This one says, why do many of the transactions lately fell on the C chain? Also, how come a transaction is broadcast, maybe not their native language, once a transaction is broadcast to the network, it sometimes takes 30 seconds or more to get it confirmed on the chain. I'm asking because I thought transactions were sub-second. Just for the sake of argument, I'm going to presume people mean C chain here. So number one, have transactions been failing a lot lately? I didn't know that. And then once it's broadcast, why do people get the user experience of it taking around 30 seconds to land?
So touching on the first comment about failed transactions. So in Ethereum, a failed transaction isn't necessarily a transaction that didn't work. And so sometimes the explorers will show like a big red X and it looks scary and it looks like something bad went wrong. It just means that the state transition that transaction was attempting to make wasn't performed. So this is extremely common with arbitrage type of transactions. So if an arbitrager issues a transaction and they aren't, say they issue a block and that block doesn't win, there's a different block that wins, that transaction can end up getting reorged into a following block, which is then going to fail because the arbitrage opportunity is gone. So the transaction is still processed, but it doesn't necessarily mean that the transaction didn't work. It's more of a nuance of the EVM. And so if you look actually on Ethereum, you'll also see failed transactions. And, whether it's a higher percentage of Avalanche transactions compared to Ethereum transactions, I don't know the metrics on that. I wouldn't be surprised just because of asynchronous block production. You might see some more race conditions with arbitragers. I don't know, but I think that kind of explains that. So I would say it's not necessarily a problem and it's healthy.
It's a problem in the DApp smart contract code or the transaction itself. It's not a problem with like the core network.
Yeah, exactly. So I think that kind of touches on that. And then the follow-up of transactions taking, a long time, that could be a number of different things. If you issue a transaction with too low of a base fee, then it will hang around in the mempool for a while until the base fee is reduced to a point that you can get it accepted. So that might be what this user is seeing. Additionally, as we kind of touched on with block contention, there can be a bit of a slowdown. I'd be surprised if it was taking 30 seconds, but I think that those are probably our explanations. I think block accept latencies are around 800 milliseconds a second, stuff like that. So I think that's kind of what we're seeing. So anything significantly larger than that probably doesn't have too much to do with the actual consensus mechanism. It's probably more around the specifics of the transaction. But I would have to look probably at the specific case to give a really detailed answer.
Gotcha.
Yeah, so I just want to say thank you to those who wrote in. So thank you, DeFi Cash Flows. Thank you, Moonsoon Season. I really like that. I really like that name. Alex Togby and Fat Twitter. I don't know.
Yeah, there's a couple.
Thank you for writing in.
Yeah, there's a couple more. We get great questions from our community. The Avalanche community is absolutely outrageous. So many smart and dynamic people from all around the world. It's truly an honor to be in the same ecosystem and to work on the same project as all you folks. It's amazing. So there's somebody here who Yesil, Yesil, he appears to be quoting our previous chat, Stephen, where he's quoting you. He says, "My first Go program is AvalancheGo." Whoa. So massive props there, rightfully so. And then here's another one. Perhaps we just touched on this one, but it says, "Why is C-chain gas price already often at the upper bound, 225 nanoavox, soon to be raised to 1.6, soon to be raised with 1.6, when the volume of activity on chain is a small fraction of what it can purportedly handle?" So in other words, why are we seeing the upper bound of the suggested dynamic fee when the network doesn't appear to be full?
So I think if we actually look at the metrics, I think it's pretty rare for it to be at 225. So certainly during extremely high bursts, the fee can shoot up, and we heard some feedback on the perhaps the network being too responsive, and so that was one of the changes in AP4 to kind of make it a little bit of a more gradual increase and decrease. So that might be something that they're seeing, but I don't recall really seeing it pegged to 225 for extended periods of time, mainly short periods. But yeah.
Okay, gotcha.
So one question I have is, I've gotten this question on Twitter before of people are kind of like shocked that we have a max gas price, because if Ethereum goes down tomorrow and everybody's like, we need a new blockchain, everybody goes to Avalanche and we get 100 XR users in like an hour. Wouldn't we would hit the fee cap rapidly, and then like nobody be able to transact or whatever, maybe if we handle that kind of load. So I guess like what is the long-term plan here, or like I guess what needs to be done? Are we eventually going to take the guardrails off entirely on the upper bound, or do we have other plans for kind of managing scalability?
So really the guardrails are just as kind of like a emergency precaution. So if there was some way to game a mechanism so that it could cause the fees to go up arbitrarily, that would be a major incident. And obviously, like we spent a lot of time making sure that wasn't possible, but we just wanted to make sure, kind of with this new fee mechanism that we implemented, we just wanted to make sure that we weren't going to really damage anything. So I think as time goes on, and really, we can see already from the transition from AP3 to AP4 that as we feel more comfortable with this mechanism and the dynamics that are happening on mainnet, we're really letting this mechanism kind of do its own thing and perform how we hope it will and how it is on mainnet. So I don't know that we'll see a time where we fully remove it because just concerns there, but I wouldn't be surprised either if we did. Like at the end of the day, I think 1,000 GUI for a fee is very high, and I would be very surprised if we actually were hitting that consistently. And if we are, then that probably says that we might still have a little bit of tuning to go on Moderato. But I think yeah, I wouldn't, I don't know. The future is a mystery, but I wouldn't be surprised if we remove it, if we feel really good about it, or if we set some very reasonable cap.
Yes, so we I just wanted to mention we have added to the Postman collection and AvalancheJS, the ETH max priority fee per gas and the ETH base fee RPC calls. So again, this is now in AvalancheJS. This is also in the AvalancheGo RPC, presumably through core ETH. I'm not 100% sure, but I'm guessing. And then this is also part of the Postman collection now. So there are RPC methods that you can call to get the base fee and the max priority fee per gas to be able to do this dynamic fee calculation. We also added just yesterday in the new 3.9 build of AvalancheJS that went live, a new constant, 2 new constants for min gas price and max gas price. The min price is 25. So this is for GUI, and then the max price is for 1,000 GUI. So again, You now have RPC calls and constants in AvalancheGo, the Postman collection, and AvalancheJS to help you with this dynamic fee calculation. So it has been 45 minutes or a little bit over. So I think I want to start kind of driving it to where we're going to wrap up. There were a couple other things I wanted to very briefly touch on, a couple other topics. Or is there anything else you guys would like to touch on from the Apricot Phase 4 1.6 release?
I think the only thing that I want to mention is touching back on the usage of GUI. I really look forward to when we don't say GUI, but we say nanoavox, because
thanks for correcting
right now,
me. That's
right,
good. Yeah.
No, I mean I said it as well, but I think that with all of the ETH tooling that just kind of works out of the box with the C chain, it gets really complicated. But I really look forward to rolling out some more like specialized and cool systems that integrate more gracefully with the Avalanche network.
So instead of telling people our min gas price is 25 GUI, I would just say it's 25 nanoavox.
That's the conversion. So
okay,
yeah,
fair enough, straightforward. Connor, any last minute thoughts on Apricot Phase 4?
No, we can. This was a great discussion. We can.
Excellent. How does this roll into Blueberry, or what is the exact sort of steps to go from Apricot to Blueberry?
Yeah, so I think we're finally wrapping up the phases of Apricot. I would say that
round of applause.
The engineering team especially is pretty sick of the Apricot name at this point. So I think we're looking forward to kind of greener pastures. So I would have to look at the roadmap for Blueberry before I said anything publicly, but I know that what we have planned for Blueberry is really cool. So that's kind of all I'll say, unless someone has a Blueberry roadmap pulled up.
I do actually have it open right now, and I was going to say, here, I'll share the link with you guys. We don't have a ton there, and again, we've been a little bit reluctant to commit to things on a timeline because we did that previously with Apricot, and we had a little bit of social blowback, so now we're being a little bit more loose. But I know I just posted you guys the roadmap. It's available online, avox.network/roadmap. If you scroll to the bottom, at least in the Q4 sections where I was looking at, there is cross subnet transfers, permissionless subnets, and subnet validation rewards. So I know there's going to be a lot of energy dedicated to subnets and virtual machines, because that's a big part of our platform, which just it's available, but it's not fully baked, and there's a lot we can do there. So do you have any thoughts about that?
Yeah, no, subnets is going to be a really big push. It's kind of the keystone of our network. It's what kind of we've been working towards. So we've definitely been playing around with subnets internally, and we have some people working on expanding that out. So really looking forward to that, because I think it's if we can continue to roll that out and we get that right, I think that it's gonna really be huge for the network. I think people are gonna really enjoy it. Already been fleshing out a lot of our custom VM stuff, and the VM plugin infrastructure is fully there. So we started to see some people implement some really interesting VMs, some of which are perhaps like doing stuff that we had never thought was possible, and it might mean that we want to better support them. I saw a couple of very interesting VMs that kind of did some very interesting loopholes. So we'll be looking into that, and I would love someone to implement. I have a bunch of ideas for some very cool VMs, so I would be very open to anyone pinging me and asking about how to implement a VM, or if they have any VM ideas, because I think it's really going to be awesome as we start to flesh that out. Yeah.
So
yes.
I do want to give a shout out to our Gitcoin hackathon participants. We ran a couple Gitcoin grants, and one of them was to build a subnet. These are some of the first subnets that have been built that we've ever seen, and so those were the ones that Stephen was referring to. We saw some really cool, interesting stuff. And yeah, no, we're super excited to see those submissions, and hopefully those will be the first of many more.
Yeah, so that was what I was going to touch on next. So there's a few really cool stuff, a few cool things happening in the developer services part of the world. So the first is what Connor just mentioned. We recently participated in the Open DeFi Hackathon, where we issued $30,000 in bounties. 15,000 was for a virtual machine and a subnet bounty, and then there was also 7,500 one for prediction market, and then there was a third one which nobody submitted to. But yeah, we got 3 submissions in our subnet and virtual machine. One of them is the event tokenizer virtual machine, another one is a file storage virtual machine, and another one is the media based virtual machine. This code is all open source, so that's why I can mention it. We're ultimately going to make the bounties available to the community. There is also another hackathon which wrapped up last week. You guys may remember that we set aside a $50,000 prize pool to have people build out tutorials for our documentation. And that wrapped up last week. Myself and the aforementioned Jovica have been going through and figuring out the final winners and basically getting their pull request integrated into our documentation. So there's some really cool stuff that came out of that, including virtual machine work and a lot of smart contract stuff. Myself, I'm actually leaving tomorrow to fly out to Wyoming. I'm going to attend the YO Hackathon, which is very exciting. I'm presenting on DAO Day, my presentation being the power of DAOs and the future of organizations. And I'm really, really excited about that. And then I'll be there all weekend where we're having, where there is a YO Hackathon, and I'll be, of course, attending as a mentor. And we are having a $5,000 bounty from Ava Labs, where it's the same thing. It's a subnet and a virtual machine bounty. So basically a $5,000 prize for the team that can come up with the best virtual machine and subnet, get it deployed live on our Fuji network and do some documentation and that kind of stuff. We have, as I mentioned, there's 3 virtual machines that recently got submitted with our Open DeFi Hackathon. There's also the timestamp VM, which exists today in the code base. You can go check this out. We have a Git repo for it. We have a tutorial which shows how to spin this up. Basically, it's a very simple virtual machine that allows you to basically take the hash of a document and timestamp it so that you can prove that it's that you basically had this intellectual property at a certain time. So I don't know if you guys are familiar with this, but there's something which, you know, colloquially has always been called the poor man's copyright. And I used to see this a lot when I was younger and I was into music. Something people would do to copyright stuff is they would take some type of intellectual property that they wanted and they would basically send it to themselves through some type of formal US Postal Service mail flow, so that it had an official USPS stamp on it. So if they ever had to go to court, they could officially, you know, break the seal in front of the judge in the court and show that, hey, I had this intellectual property on this particular date. It's, you know, one of the reasons people suggest that Satoshi timestamped the Genesis block, you know, on the brink of bailout for banks or whatever it was, whatever the headline is, basically to show people, like, there used to be a thing where people would take a picture of themselves next to a paper and the timestamp on the paper would prove that they had this idea or whatever at this certain time. This timestamp VM accomplishes that by allowing you to take the hash of a document and then basically just timestamp it into the blockchain. So that exists today. It's called the timestamp VM. You can go fork that repo and start building out your own virtual machines. So this weekend, if you are able to make it and you're in the United States, I highly, highly recommend joining myself and some other people at the University of Wyoming in Laramie. There will be a hackathon. We have a $5,000 bounty for the virtual machine and subnet bounty. And then the other thing I thought would be worth touching on, Connor, and I'll you know, leave it at your discretion how far down the rabbit hole you want to go. But there was recently just another huge release on the NFT platform, and I just thought I might give you a chance to plug that and plug all your amazing work you're doing there.
Yeah, we recently released MLB Inception, which was a fantastic success. We sold out very quickly. Yeah, I think that platform is doing some really cool stuff. It's really awesome working with such great partners and really fantastic content teams that are creating some really awesome NFTs. I think we really are doing some really interesting technical stuff on the back end. So it's been really cool to build some stuff that gets to integrate some of the best of Web 2 and makes NFTs even more accessible by letting you buy with a credit card and some stuff like that. And it's not the last you've seen of you know, Topps NFTs, and there's going to be a lot more cool releases, you know, in the near future.
Again, with the stated intention being we want Avalanche to be the premier platform for launching licensed NFTs. So, in the all of 2020, the entire NFT marketplace was 250 million. In Q1 of 2020, the entire NFT marketplace was 2 billion. So, it had an 8x increase or something like that in 1 quarter compared to the whole year. And so, NFTs are going mainstream. I'm a big believer in NFTs. NFTs will potentially be as meaningful as, cryptocurrencies themselves, that distinguish between like a variable or fixed cap asset and a non-fungible token. As the world undergoes this convergence of the analog and the digital, and we recreate most of our world in these new virtual and augmented realities, NFTs are going to play an absolutely huge role in that whole transition. And so we just view Avalanche as the premier platform for launching licensed NFTs. And we anticipate there being even more really big existing traditional brands that have all of this IP and all of these great licenses and brands and characters and worlds, virtualizing them and tokenizing them on the Avalanche network. And of course, Connor's work is going to be absolutely critical there. So I think that's it. That's everything I had on my list, you guys. I think we can probably bring it to a close. I'll just pass the mic around one last time and give final shots, final thoughts, shout outs, anything you guys want to mention. Stephen, go first.
Yeah, no, just really happy that you guys invited me back here. It's always a blast. Big shout out again to the platform team for everything they've done. Big shout outs to Patrick, Alberto, Dan, Aaron. The whole testing team was amazing at this. So Felipe, Fabio, Pedro. I'm missing people, but I couldn't say them all. But everyone has really been phenomenal these past few days focusing on Snowman ++, and super proud of how everything went.
Yeah, and we're always hiring. So if you want to go check out avalabs.org/careers, we are hiring across the board, not just engineering, but literally we got business operations, engineering, marketing, finance, product, just across the board. We're absolutely trying to hire the best and brightest and most creative, easy to get along with, hardworking people on the entire planet. So if anything we talked about today turns you on, please reach out to us. We're always looking to bring people into our team. Thank you, Stephen. Connor, any thoughts?
Stephen, you've been a good guest, but if you want to come on for visit number 3, you're gonna have to ship another platform upgrade. So.
Oh, okay. Well,
yeah.
I might just get an invite then. I don't know. We'll see how it goes. But again, it's been amazing talking to both you, Gabriel, and you, Connor. So I'm always happy to join.
All right, yeah. So for now, if you want to follow me, you can find me on Twitter at DAS_CONNOR, Das Connor.
Yeah, I'll make sure to put the links below to the AvalancheGo 1.5 and 1.6 builds. I'll put the new stats dashboard. I'll put any documentation. We had a Medium post recently about Apricot Phase 4 with the Snowman ++ and all that good stuff. I'll put all of our Twitter handles as well. That it? No other shout outs, Connor?
Nope. Yeah, you're good.
All right. Okay, you guys, thank you so much. This has been another episode of the Subnet Show. If you made it this far, thank you. You're an absolute champion. Again, if you're in the United States and you can make it this weekend at the WIO Hackathon, I will be there. It's going to be an absolute blast. And we will catch you on the next episode of the Subnet Show. And so from Snowflake to Avalanche and through consensus to the stars. Thank you, ladies and gentlemen.